Module 13 on network virtualization. Yeah. Right. In here, yeah, objective module is explain the purpose and characteristic of network virtualization. Yeah. So topic title, we have cloud computing. Okay, it will explain the importance of cloud computing. And then virtualization, explain the importance of virtualization. Virtual network infrastructure, describe the virtualization of network devices and services. And SDN, software defined network, describe what is software defined network or SDN. And finally is controller, describe controller used in network program. All right. First, we go to cloud computing. Okay, this video will cover the following data center, cloud computing, virtualization type 1, hypervisor type 2, hypervisor. Yeah. Okay, let's see the video first.
In general, when we talk about the cloud, we're talking about three things: data centers, cloud computing or cloud services, and virtualization or virtual computing. Though data centers can be smaller, they're generally large facilities which provide massive amounts of power, cooling, and bandwidth. Only very large organizations like Facebook or Google can afford their own centers to provide services to their users. Other smaller organizations lease space from a data center. Cloud service providers like Cisco or Amazon Web Services or Microsoft Azure offer their services out of data centers. There are two basic types of clouds: public clouds and private clouds. Public clouds offer services and applications to the general population, whereas private clouds are intended for specific organizations or entities, such as governments, and are only accessed by those private organizations. There are different categories of cloud services. SaaS, or software as a service, refers to on-demand software or a subscription model where the license and delivery of the software happens through the cloud. You'll find this with things like Office 365 or Adobe Creative Cloud, or even computer gaming software in which access to the software happens typically through a web browser. The software is typically not owned, but rather leased. PaaS, or platform as a service, is where the cloud service provider provides the platform, like the Java or .NET platform for a developer to develop an application or app. This oftentimes involves providing databases and tools to the developer so that they can quickly develop an app. Infrastructure as a service refers to virtual computing that can be provided over the internet on demand. This includes virtual computing such as virtual servers, as well as virtualized storage and virtualized networking capabilities that can be provisioned, allocated, and supplied on demand on an as-needed basis. Virtualization is the ability to abstract or separate the operating system from the physical hardware. To create a virtual computer, the dedicated physical hardware needs to be shared with the virtual computer. In this slide, we see a Windows 7 virtual computer that is sharing the physical dedicated resources of the host computer. This is done through a hypervisor. There are two types of hypervisors used in virtualization, a type 1 hypervisor known as a bare metal hypervisor and a type 2 hypervisor known as a hosted hypervisor. A type 1 bare metal hypervisor is a virtualization server. The hypervisor is an operating system that's installed onto the hardware directly, after which virtual computers can be created. There are different types of type 1 hypervisors: KVM, Red Hat Enterprise Virtualization, Xen, Citrix Xen Server, VMware ESXi, VMware vSphere, and Microsoft Hyper-V. A type 2 hypervisor is known as a hosted hypervisor. In this situation, the hypervisor is an application or program that's installed on top of the host operating system. In other words, you install the hypervisor like VirtualBox or VMware Workstation, Parallels Virtual PC on top of the host computer. You install VirtualBox, let's say, on top of the Windows operating system, and then you can create virtual computers. In addition to virtual computing, we can also virtualize switching and routing. In this slide, we can see two VMware ESXi hypervisors. The virtual computers are all networked together with a Cisco Nexus 1000V virtual switch. The virtual switch brings the power of a Cisco switch to the virtualized network environment. In general, when we talk about the cloud, we're talking about
All right. Okay. Cloud overview. Cloud computing addresses a variety of data management issues. Yeah. Enable access to organizational data anywhere and anytime through cloud. Yeah. So streamline the organization IT operation by subscribing only to needed accesses, services, so on demand. So eliminate or it can reduces the need for on-site IT equipment, maintenance, and also management. Reduce cost for equipment if you have a cloud, energy, physical plant requirement, and personnel training needs. Enable rapid response to increase data volume requirement. Cloud services. The three main cloud computing services defined by National Institute of Standard and Technology, or NIST, in their special publication, 800 to 145, are as follow. Software as a services, SaaS. The cloud provider is responsible for access to application and services that are delivered over the internet. Platform as service or PaaS. The cloud provider is responsible for providing users access to the development tools and services used to deliver the application. Infrastructure as a service, IaaS, The cloud provider is responsible for giving IT managers access to the network equipment, virtualized network services, and supporting network infrastructures. Cloud service providers have extended this model to also provide IT support for each of the cloud computing services. For businesses, IT's what we call this IT support for each of the cloud services. Yeah, ITaaS can extend the capability of the network without requiring investment in new infrastructure, training new personnel, or licensing new software. There are 4 primary cloud models. We have a public cloud, private cloud, hybrid clouds, and also community clouds. So what are these? So cloud-based, for the public cloud, is a cloud-based application and services made available to the general population. And for the private, cloud-based application and services intended for a specific organization or entity, such as government. Hybrid cloud is made up of 2 or more clouds. Yeah. For example, part private or part public, where each part remains a separate object, but both are connected using a single architecture. Okay, so meaning that in hybrid cloud, there are 2 types, private and public. Yeah. All right. Community cloud. A community cloud is created for exclusive use by specific community. The differences between public cloud and community cloud are the functional needs that have been customized for the community. For example, healthcare organization must remain compliant with policies and laws. For example, HIPAA, yeah, that requires special authentication and confidentiality. Okay, cloud for the community. All right. So cloud computing versus data center. These are the correct definition of data center and also the cloud. So data center means typically a data storage and processing facility run by an in-house IT department or leased offsite. Data centers are typically very expensive to build and maintain. Cloud computing, typically an off-premise service that offer on-demand access to share pool of configurable computing resources. These resources can be rapidly provisioned and released with minimal management effort. Okay, data center are the physical facilities that provide the compute, network, and storage needs of cloud computing services. Cloud service provider use data center to host their cloud services and cloud-based resources. All right. Virtualization. Yeah. So cloud computing and virtualization. The term cloud computing and virtualization are often used interchangeably. However, they mean different things. Virtualization is the foundation of cloud computing. Without it, cloud computing as it is most widely implemented will not be possible. Virtualization separates the operating system from the hardware. Various providers offer virtual cloud services that can dynamically provision servers as required. These virtualized instances of servers are created on demand. Okay. Dedicated servers. Historically, enterprise servers consisted of a server OS, such as Windows Server or Linux Server installed on specific hardware. All of servers, RAM, processing power, and hard drive space were dedicated to the service provider. For example, web, email, services, etc. When components fail, the service that is provided by this server becomes unavailable. This is known as a single point of failure. Dedicated servers were generally underused. They often sat idle for a long period of time, waiting until there was a need to deliver the specific service they provide. These servers wasted energy and took up more space than was warranted by the amount of service provided. This is known as server sprawl. All right. Server virtualization. Server virtualization takes advantage of idle resources and consolidates the number of required servers. This also allows for multiple operating systems to exist on a single hardware platform. The use of virtualization normally includes redundancy to protect from a single point of failure. The hypervisor is a program, firmware, or hardware that adds an abstraction layer on top of physical hardware. Okay, on top of physical hardware. The abstraction layer is used to create virtual machine which have access to all the hardware of the physical machine, such as CPU, memory, disk controller, and also NIC or network interface card. Okay. Advantages of virtualization. One major advantage of virtualization is overall reduced cost. Less equipment is required, less energy is consumed, less space is required. These are additional benefits of virtualization. Easier prototyping, faster server provision, increased server uptime, improved disaster recovery, and legacy support. Right, abstraction layer. A computer system consists of following abstraction layers: services, operating system, firmware, and also hardware. At each of these layers of abstraction, some type of programming code is used as an interface between the layer below and the layer above. A hypervisor is installed between the firmware and also the OS, between these. So the hypervisor can support multiple instances of operating system. Okay. Okay. Type 2 hypervisor. A type 2 hypervisor is software that creates and runs VM, virtual machine instances. Yeah. A computer on which a hypervisor is supporting one or more virtual machine is a host machine. Type 2 hypervisors are also called hosted hypervisors. A big advantage of type 2 hypervisor is that management console software is not required. Now, virtual network infrastructure. Type 1 hypervisor. Type 1 hypervisor are also called the bare metal approach because the hypervisor is installed directly on the hardware. Type 2 hypervisor can usually use on enterprise server and data center networking devices. And with type 1 hypervisor, the hypervisor is installed directly on the server or networking hardware. Then instances of OS are installed on the hypervisor as shown in the figure. Okay. Type 1 hypervisor have a direct access to the hardware resources. Hardware resources. Therefore, they are more efficient than hosted architecture. Type 1 hypervisors improve scalability, performance, and robustness. Installing a VM on a hypervisor. VM stands for virtual machine. Type 1 hypervisor require a management console to manage the hypervisor. Management software is used to manage multiple servers using the same hypervisor. The management console can automatically consolidate servers and power on or off servers as required. The management console provides recovery from hardware failure. If a server component fail, the management console automatically move the VM to another server. Cisco Unified Computing System, or UCS, manager controls multiple servers and manages resources for thousands of virtual machines. Some management console also allows server over-allocation. Over-allocation is when multiple OS instances are installed, but their memory allocation exceeds the total of memory that a server has. Over-allocation is a common practice because all 4 OS instances rarely require all their allocated resources at any one moment. Okay, so there's the advantages of that. Okay, the complexity of network virtualization. Server virtualization hides server resources. This can create problem when using traditional network architecture. VM, or virtual machine are movable, movable, and the network administrator must be able to airdrop and change network resources, including profile to support their mobility. This process will be manual and time-consuming with traditional network switches. Traffic flow differ from the traditional client-server model. Typically, there is a considerable amount of traffic being exchanged between virtual servers, like east-west traffic, then changes in location and intensity over time. North-south traffic is typically traffic destined for off-site location, such as another data center, other cloud provider, or the internet. All right. So dynamic ever-changing traffic require a flexible approach to network resource management. Existing network infrastructure can support to changing requirement related to the management of traffic flow by using QoS, or quality of service, and security level configuration for individual flows. However, in large enterprises using multi-vendor equipment, each time a new VM is added, the necessary reconfiguration can be very time-consuming. The network infrastructure can also benefit from virtualization. Network function can be virtualized. Each network device can be segmented into multiple virtual devices that operate as independent devices. Examples include sub-interfaces, virtual interfaces, VLAN, and routing table. Virtual routing is called virtual routing and forwarding, VRF. Software-defined network, or we call that SDN. Okay, so this video will cover the following: network programming, SDN, which is Open Network Foundation, OpenFlow, OpenStack, and some info regarding controller. All right.
Network programming is used to program and virtualize the network. We're talking about protocols, programming, scripting, data modeling, and markup languages, as well as architectures and APIs, or application programming interfaces. Protocols like the OpenFlow protocol which allows a programming language to control the forwarding plane of a switch or a router, as well as netconf and restconf. Programming languages like C, C++, Java, scripting languages like Python, Ruby, and Lua, data modeling languages like Yang, markup languages XML, and architectures and APIs like the REST architecture and API used over a web browser, and the Java API with all of its libraries and pre-written classes and blocks of code. SDN, or software-defined networking, is an approach to networking where the network is software programmable remotely. It involves the Open Network Foundation, which supports the concept and the development of SDN, and has also been responsible for releasing the OpenFlow protocol or standard, which is a protocol that separates the control plane from the forwarding plane in switches and routers. Also listed here is OpenStack, which is a software platform for cloud computing and providing IaaS, or infrastructure as a service, which means the ability to manage pools of processing power, virtualized servers, and network storage on an as-needed basis for the customer through a data center. In this image, you can see a comparison between a traditional architecture and an SDN architecture. Notice how in the traditional architecture, each device, device 1, device 2, and device 3, let's say they're network switches, each device has a control plane and a data plane. And so to configure those devices, you configure the control plane on each of those devices. In an SDN, or software-defined networking architecture, notice how the control plane has been separated from the data plane. And now the three devices, let's say there are three switches, could be controlled from a single control plane or from a single controller using the OpenFlow protocol. This way, the three switches can be programmed from a single point or a single software program. In this image, you can see this example further. In this case, the application has been developed using Cisco's 1PK Open Network Environment Platform Kit, and the software has been written in, let's say, the C or Java or Python programming languages, and the application can program the data plane on the three switches, device 1, device 2, device 3, using the OpenFlow standard. Network controllers are SDN control plane devices, which are a programmable point of automation to manage, configure, monitor, and troubleshoot virtual and physical network infrastructures. This automates the configuration of the network infrastructure. Network controller is a hardware device which locates the SDN control plane. An example of a network controller used in SDN, or software-defined networking, might be the Open Daylight platform. The Open Daylight platform is an open source SDN controller platform. You can see in this example where the SDN controller works with an application to then control the network devices, here listed as device 1, 2, and 3 at the data plane. The Cisco ACI, or application-centric infrastructure, is Cisco's approach to software-defined networking and network controllers. It involves three main things: an ANP, or application network policy, an APIC, application policy infrastructure controller, in this case the APEC EM, which is the enterprise module for APIC, and switches that are application programmable, like the Nexus 9000 series switches. In this example, we can see how the Cisco APEC EM works. The APEC EM, or enterprise module, is the SDN controller which sits between the application and policy and the data plane devices, device 1, 2, and 3.
Okay. So now control plane and data plane. Yeah. Okay. A network device contains the following plans. Control plans. This is typically regarded as the brain of device. Means that they're very important. Yeah. It is used to make forwarding decision. The control plane contains layer 2 and also layer 3 route forwarding mechanisms such as routing protocol, neighbor tables, and also topology tables. IPv4 and IPv6 routing table, STP, and also ARP. Information sent to the control plane is processed by the CPU. Yeah. So data plane, also called the forwarding plane. This plane is typically the switch fabric connecting the various network ports on a device. The data plane of each device is used to forward traffic flows. Router and switches use information from the control plane to forward incoming traffic out the appropriate egress interface. Information in the data plane is typically processed by a special data plane processor without the CPU getting involved. CEF is an advanced layer 3 IP switching technology that enables forwarding of packets to occur at the data plane without consulting the control plane. SDN is basically the separation of the control plane and also data plane. The control plane function is removed from each device and is performed by a centralized controller. So this centralized controller communicates control plane function to each device. Each device can now focus on forwarding data while the centralized controller manages data flow, increases security, and provide other services. And then the management plan is responsible for managing the device through its connection to the network. The network administrator use applications such as SSH or secure shell, trivial file transfer protocol, TFTP, secure FTP, secure hypertext transfer protocol, or HTTPS to access the management plan and configure a device. The management plan is how you have access and configure devices in your networking studies. In addition, protocol like SNMP or simple network management protocol use the management plan. So network visualization technologies. Two major network architecture have been developed to support network virtualization, SDN or software-defined networking. A network architecture that virtualizes the network, offering a new approach to network administration and management that seeks to simplify and stream the administration process through SDN. Okay. And Cisco Application-Centric Infrastructure, ACI, a purpose-built hardware solution for integrating cloud and also data center management. Component of SDN may include the following items. First, OpenFlow. Second, OpenStack. Third, other component. OpenFlow. This approach was developed at Stanford University to manage traffic between routers, switches, wireless access point, and also controller. The OpenFlow protocol is basic element in building SDN solution. OpenStack. So this approach is a virtualization and orchestration platform designed to build scalable cloud environment and provide an IaaS solution. OpenStack is often used with Cisco ACI. Orchestration is in networking is the process of automating the provisioning of network component like server, storage, switches, routers, and other applications. Other components include interface to the routing system, I2RS, transparent interconnection of lot of links, TRILL, and Cisco Public Path, FP, and IEEE 802.1 AQ, shortest path bridging, SPB. Traditional and SDN architecture. In traditional router, or switch architecture, the control plane and data plane function occur in the same device. Routing decision and packet forwarding are the responsibility of the device operating system. In SDN, software-defined network, management of the control plane is moved to a centralized SDN controller. The figure compares traditional and SDN architecture. Okay, this is traditional, and this is the new architecture currently. A lot of manufacturer use this. Right. Okay, we continue. Same topic. Regarding traditional and SDN architectures. The SDN controller is a logical entity that enable network administrators to manage and dictate how the data plan of switches and routers should handle network traffic. It orchestrates, mediates, and facilitates communication between application and network element. So the complete SDN framework is shown in the figure. Note the use of application programming interface, or API. An API is a standard definition of the proper way for an application to request services from another application. SDN controller use node-bound API to communicate with the upstream application, helping network administrators shape traffic and deploy services. The SDN controller use southbound API to define the behavior of data plans on downstream switches on routers. OpenFlow is widely implemented, southbound API. Controller. Okay.